post the times. So we said here, we said 2 to 4 p.m. I'll open it earlier. And here we said 3 to 6, 3 hours. If we need to adjust that, we will. Okay, so last section, and next week we will review. I send you an email about the bonus, and I also posted a previous test 3. So please look at that. So there are 3 topics that we have to talk about finally in section 8.1. We have to look at sequences. And the next topic is factorial notation. Okay, let me see what you see. Okay. So sequences, factorial notation, and summation notation. We're going to start with the easiest, with the factorial notation. The factorial notation is something like, and here's an example. Let's say 6 factorial. This is nothing else but a product of numbers. Which numbers? We always start with the one we see, the one we are given, subtract 1, subtract 1, subtract 1, subtract 1, and we have to stop at 1. We don't continue to 0 or to negative numbers. So can I determine this? Yes. This is 30. I'm trying to make it easy. This is 8. 30 times 8 is 240, and then I have to multiply by 3. So the answer is 0, 2, and I carry 1, 6, and 7. Is there a way of doing this with a graphing calculator? Yes, quite an elegant way. So let's go to math. We have to scroll to the right to probabilities. So go to probabilities, and you see the symbol of the exclamation symbol, the factorial symbol is number 4. So don't do anything, just quit for a moment, and we have to put 6 first. 6 gets in first. Then we go to math, all the way to probabilities, scroll down or select 4, it doesn't matter. So now we see 6 factorial. When I click enter, I have to get 720. And that's 720. Now, careful with factorials, because the numbers can get very, very big, very fast. And for example, if you want to just put 240 and factorial, I don't think that the calculator can do this. It gives us an error. It doesn't have enough memory, enough space to come up with that number. It cannot calculate that number. It's that big. So careful with that. Okay, one more piece of information here is that 1 factorial obviously is 1, but what you wouldn't expect is that 0 factorial is also 1. So keep that in mind. For things to work, 1 factorial and 0 factorial are the same. What is the general formula for this? Because it can be anything, right? So if it's n factorial, we follow the same pattern. We always start with the number we are given. So I have to start with n. How do I get the next one? I multiply by a number that I subtract 1 from the previous one. And multiply by, I subtract 1 from the previous one. I subtract 1 from the previous one. 3 dots. 3 times 2 times 1. So no matter what this number is, I will end up till 1. Okay, so now can I simplify factorials? Yes, I can. And here's an example. Let's say I have 15 factorial divided by 12 factorial. The calculator may be able to give us this number, but I can simplify it without the use of the calculator. And sometimes when I have n in this expression, I will not be able to put in the calculator. So I'm asking myself, which of these two is bigger? Well, obviously 15 is bigger than 12. So I can start by writing 15, and then the next in line must be 14, and the next in line must be 13. The next in line must be 12, but I want to stop at 12 factorial, of course, because I have to continue till 1. Instead of continuing till 1, I stop because I see the denominator as being 12 factorial. And that is very elegant. And I'm done. And the answer, what would that be? It would be 15 times 14 times 13. 15 times 14 times 13, and I get 2730. 2,730. Okay, let's look at a couple of examples from your book. I'll let you choose if you'd like. And this is section 8.1. On page 752. Let's start with 25. 752. And we have 16 factorial divided by 2 factorial multiplied by 14 factorial. Don't try to simplify in any way, shape, or form, or try to multiply these two and say it's 28 factorial. That's not how the factorials work. You can't touch anything. You just you can only think in terms of which one is bigger. Well, obviously 16 is bigger. And can anyone tell us what should I write at the top? Because eventually I want to simplify this. And then we'll look at an example that has variables. Of course, one variable. So what should I write at the top? Keeping in mind that the denominator is 14 factorial. Is there any way I can simplify?
Would you write 16 times 15 times 14 factorial?
Very good. And then 2 factorial is 2 times 1, so it happens that this is the same with 2. Perfect. Times 14 factorial, and of course, I make my life as easy as possible if I can. I simplify by 2, and the answer will be 8 times 15. I think it's 110. 120. 40, and yes, 120. Can I put this in the graphing calculator? Yes, I can. From the very beginning, if the numbers are not too big, the calculator will give us the answer and it has to be the same. Here's another example of factorials before we move on to the next topic. Or, of course, I'll let you decide if you want more examples, of course. Let's say 27. Same page, of course, 752. So we have n plus 2 factorial divided by n factorial. We can put this in the calculator, but we can still simplify it. Again, I'm asking myself the same question. Which one is bigger, n plus 2 or n? Remember, n can only be a number between 1, 2, 3, ... infinity, but it has to be a positive integer, not 0.
So the top one, n plus 2.
Actually, yes. Actually, it could be 0 because 0 factorial is 1. Okay, perfect. So yes, n plus 2 is bigger, so I will not touch n factorial. But now the question is, what do I write instead of this? And where do I stop? So n plus 2 factorial, I have to start with what I see. What will be the next factor?
N plus 1.
Very good. Thank you. I subtract 1 from this one. Now what will be the next factor?
N factorial.
N factorial. Thank you. And I'll stop because I see this. So then the simplified form of this expression will be, after I distribute, I get n squared plus 3n plus 2. And this is how factorials work. We have other types of problems, but we have to look at the other two topics before we choose more with factorials. Do you think we should choose something else, another simplification or something else with factorials for now? Or is this okay?
I don't want to speak for everybody because I've done 8.1.
Okay, very good. So then we continue. You can always stop me and we'll have more examples when we finish with the other two. Okay, number 3. Summation notation. Also called sigma notation. Same thing. Okay, so let's take a look at the following scenario. Let's suppose I want to add 1 to the third power, to 2 to the third power, to 3 to the third power, 3 dots, to 20 to the third power. First question is there a way of writing this in a condensed way, in a condensed form? So I don't have to list all this. I just want to write a notation that gives me all this, but I don't have to write it anymore. Well, since this is a summation, a sum of terms, we're going to use a letter that represents the sum. We could have used this one, which is the Latin S. However, it's not convenient. You'll see in a moment why this notation is not convenient. This word signifies the S in Greek. So the Greek S is not called S, but sigma. This notation is very convenient. The Greek S looks like this. Why is this convenient? Because I have to write something at the bottom of it, I have to write something at the top of it, and I also have to write something in this spot. The S was not convenient. So the Greek S is. Okay, now here is how we think about it. We notice that all these 3 terms have the same power. Okay, so something here will have that power, obviously. Now, I see that the first number, the first term is 1. The second term is 2, ... and the last term is 20. So obviously, we are adding terms from 1 to 20. And the question is of what? So first of all, let's identify this number is called the lower limit of the sigma or summation notation. Obviously, this will be the upper limit of the summation notation. And now we have to use an index. An index which normally is I or J or K. Can I use A? Of course you can use A. Can I use B? Yes, of course you can use B. But these are the most common indices. Okay, let's say I'm going to use K. So from K equals 1 to 20. So when K is 1, I get 1 to the third power. When K is 2, I get 2 to the third power. And so on and so forth. When K is 20, I get 20 to the third power. So what fits in here? What should I put? What is the general term? Well, it has to depend on K. Because when K is 1, I have 1. When K is 2, I have 2, ... When K is 20, I have 20 to the third. And in this case, it's simply K. So now I no longer need to write all this. if I'm told the sum from k equals 1 through 20 of k to the third, it's the sum. I know when k is 1, I have 1 to the third, when k plus 2 to the third, plus 3 to the third, plus 4 to the third, plus dot, 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 plus 20 to the third. And this is what we call the sigma notation. It has to have a general term or a term that depends on the index, something with the index. It could be just a number, it's possible, but in general we have something that involves k or j or I, and it goes from 1, in this case, from the lower limit, which is 1 for this problem, and to 20, because that's where it stops. So here's another example, and then I'll show you how we calculate this. So let's say the sum from I equals 1 to 4, and let's say from I plus 1 squared. First of all, what does this mean? And how many terms do I have? Well, from 1 to 4, I have when I is 1, when I is 2, when I is 3, when I is 4. So I have to have 4 terms. I just want to expand this just for us to see how it looks. And then we'll go back and calculate that and calculate this also. So can anyone give us any of these terms? We decided that there must be 4 terms. So what will be the first term?
1.
When I is 1.
So 1 plus 1.
Thank you. When I is 2.
2 plus 1.
When I is 3.
3 plus 1.
Very good. Can I do this by hand? Yes. But if you give me this number to be 20 or 30 or 40, it will take me a long time. So I'll show you how we calculate this with the calculator. So 1 plus 1 is 2, 2 squared will be 4. 2 plus 1 is 3, 3 squared will be 9. 3 plus 1 is 4, 4 squared is 16. 4 plus 1 is 5, 5 squared is 25. So this is 20 plus 25 is 45, and this is 54. So now here is these sophisticated calculators. The previous calculators did not have this notation, but these ones do. So we go to math again, and this time just scroll up. When you scroll up, you'll see under 0, it says summation notation. So press 0. The calculator doesn't have I, J, K, anything else but X. So we'll put X from 1. Doesn't have to start at 1. In this case, it does. To up till 4. And these are the parentheses of the formula. I like to put another set. You can say it's redundant. It could be. Sometimes it needs it, sometimes it doesn't, sometimes it calculates with it, sometimes it doesn't, so I just don't want to make a mistake. And when I press enter, I have to get 54. And I got 54. Now let's also calculate the other one. So go back to math, go up to 0, summation notation. It's from k, or in other words, x equals 1. And up until 20, and I want, and again I put parentheses, and that's x, and close, and power 3. And when I hit enter, because I did not calculate that one, it's way too much, I get 44,100. So all this, 44,100. Okay, so now let's make a combo. The factorial notation with the sigma notation. And then we will look at, I think I should do that first. I want to do that first. 3 properties. Of sigma. Sigma has 3 properties. Here is one property, and I'm just going to give examples. I'm going to present the first 2 together. You'll see why. Let's say I'm just making up an example. from I equals 1 through 10 from I squared plus I cubed. I can write the first term as 1 squared plus 1 cubed. The second term, 2 squared plus 2 cubed. The next term. However, I can also do this. I equals 1 through 10 from I squared plus the sum from I equals 1 through 10 from I cubed. In other words, if I have a sum of two generic terms or two general terms, I'm not distributing. This is not a distributive law, but I can say, okay, if I calculate the sum of A plus B, I can calculate the sum of A plus the sum of B, and that's what this means. The reason why I put these two together is because if I have minus, then I have minus. It's basically the same property. And now there is one more.
Can you slide your paper to the left? Thank you.
Is this better?
Yes.
Now, if I have the sum, let's say, from I equals 1 through 4, from 3 times I squared, the constant can be taken outside. If it's a factor, and it is a factor. So this is the same with 3, the sum from I equals 1 through 4 from I squared. So these are the properties that we are going to use. Okay, so let's look at a few situations here. Here's one. Let's look at 33. I'm trying to avoid the problems I've done at 2 o'clock. We worked on at 2 o'clock. So we have as many as possible. So k plus 4. So from k equals 1 through 5, first of all, let's establish how many terms will this be.
5.
Yes. And let's write them. I just want to see them first and see how this works. And then we are going to calculate. This is not a constant. I cannot take it outside. I could distribute and then separate into two sums. I can do that, but there is no need. So when k is 1, I have 1 multiplied by 1 plus 4. Plus. Why plus? Because that's the sigma. It's plus. Adding. Plus. When k is 2, 2 plus 4. When k is 3, 3 plus 4. When k is 4, 4 plus 4. When k is 5, 5 plus 4. Can I do this by hand? Yes, quite fast. But let's do it with a calculator. So go back to math, go up to the summation notation from x equals 1 and goes up to 5. And again, I put parentheses around this, so I have x and in parentheses x plus 4. Close the parenthesis and close another one. And I press enter. I got 115.